Okay, I was hoping to show you this while writing it out, but technology problems made that not happen. So I'm going to attach it as a PDF, and you could, if you want, first print it out and then look over your paper, or you can just follow along on the screen. So I'm doing problem 27 from the packet, and I actually don't have it in front of me, but the deal is I'm sure it's some sort of a box. I think it's a box of paper, and there are two different possibilities for the coefficient of friction. You can see that's the static one and that's the kinetic, and as we talked about in class, the kinetic one is smaller than the static. So the deal is first, you have to find the Fn, and I know it's annoying, but you have to go through the Fnet vertical and just look at the vertical forces and what's going on vertically. So I set up to be positive, and your two vertical forces are Fn and Fg, and they gave you that Fg was 24 newtons because they said it was the weight. So you go through your Fnet equations. Fnet v equals 0 because it's not moving vertically. Fnet v is also equal to Fn plus Fg. That's the vector sum. You apply the reference frame. I said up was positive, so it's Fn minus Fg. Plug in your numbers, and as you probably would suspect, the normal force is 24 newtons. Okay, no surprise there. And then you find the static friction, the maximum static friction, using this formula, mu s Fn. Plug in your numbers. Remember, mu s is 0.5. We just found Fn is 24, and you get 12 newtons. And so what they're asking is, if you push with 2 newtons, is that enough to overcome the maximum static friction? And the answer is no. 12 newtons is less than 2 newtons is less than 12 newtons. The applied force is less than the maximum static friction, so you can't overcome static friction. Okay. Then they say, well, what if you push with 15? Is that enough? Yes, because 15 is bigger than 12, so it will move. And since it's moving, now we've got a different story. We've got kinetic friction. And so you need to look at the whole picture and say, all right, well, now that I'm pushing with 15, I've got kinetic friction. Let me calculate kinetic friction. And then I will look at the horizontal forces and figure out the acceleration. So here's the kinetic friction calculation. I stuck in mu k, which was 0.45, and I got that number, 10.8. And then we're going to do the equation. So I'm doing the steps, always important, to do the steps for the horizontal forces. So Fnet horizontal is ma. There is acceleration, so we'll see what that is. And Fnet horizontal is the sum of the vectors, so applied force and kinetic friction. I'm applying the reference frame, which, oops, I forgot to draw, but let's say that to the right in my drawing is positive. And so 15 minus 10.8 gives you 4.2. That's your net force in the horizontal direction. We're going to plug that in over here. So 4.2 equals the mass times the acceleration. But wait, we don't know the mass. We only know the weight. Sorry, I have little pop-ups on my computer. Just ignore them. So let's figure out the mass. Not so hard. Here's the weight equation. Fg equals m times 9.8. 24 equals m times 9.8, so m equals 2.45. We're going to plug that in, and so 4.2 equals 2.45a, and you solve for a, and with sig figs, it's 1.7 meters per second squared. All right, if that was too fast, go ahead and pause it and think about it, or maybe try it on your own. But that's it. Okay, good luck.